Okay, I already said, but now we're on camera, so I'm going to say it again. A matrix is orthogonal if its inverse is equal to its transpose. Now that says things about the rows and columns and so forth that are important to understand, but let's just deal with an example of what this might mean. And I also commented that orthogonal matrices have properties kind of related to properties of Hermitian matrices, and Hermitian matrices are the matrices that represent the Lagrangians for anything in quantum mechanics. And don't ask me to explain that too much more deeply, because I've never had a really good course in quantum mechanics, but it all comes down to linear algebra. Okay? And quantum mechanics pretty much governs the universe, as far as we can tell. It's the most successful theory of physics we have, so it's really important stuff. So matrices and linear algebra are extraordinarily important in many fields, especially if you're trying to get to the fundamentals of the universe. Okay, and Hermitian matrices come up if you have complex valued vector spaces that we cover later in the course. Okay, matrix is orthogonal if its inverse is equal to its transpose. Okay, what's that mean? Well, let's just take matrix A equals 2, 3, negative 5, 4, and see if this matrix is orthogonal. Okay, well, A transpose, you just switch the rows to columns. And A times A transpose, well, that's 2, 3, negative 5, 4, multiplied by 2, negative 5, 3, 4. Okay? And, 2 times 2 is 4, 3 times 3 is 9. That gives you 13. Well, right away, you see that you're not getting the identity here, because you have to have a 1 here. Okay, so A times A transpose is not going to equal the identity, which means A is not, or that A transpose is not the inverse of A. Okay, in almost any matrix you choose, the transpose is not going to equal the inverse. Now I could finish this, and I might as well since I've written it down. Let's see, you get negative 10 and 6. Check me again, I'm doing this fast. Negative 10 and 12 is 2. And 25 and it's 41. I think that's the product. The important thing is A transpose is not the identity, so A transpose is not A inverse, so A is not orthogonal. Now, a couple of things about orthogonal matrices, and this is off the top of my head, so if I misstate something, I'll try to catch myself, but I think I can say this pretty clearly. The dot product of the first row with the second row, or row 1 times column 1, I'll write it this way because if I use an X it's like a cross product. If I use a dot, it's a dot product. It's essentially the dot product. In order to get 1 here, which we would need, the 2, 3 dotted with the 2, 3 would have to give you 1. Okay? Row 1 times any other column. I said row 1 times column 1 is 0. It has to be 1. So we've got to get a 1 there. Okay? Row 1 dotted with any other column has to be 0. For example, row 1 times column 2 would go there, and that would have to be 0 to give you the identity. There's no mystery to this. Row 2 times column 1 would have to go here. If this is the identity matrix, that's the 0. Row 2 times column 1 goes here, and that would have to be 1. So we can say row I multiplied by column J equals 1 if I equals J, 0 if I is not equal to J, and that equals delta Ij, Kronecker delta, which is equal to 0 if I is not equal to J, and equal to 1 if I is equal to J. Okay, that's important notation that you're probably going to see at some point in the course, but maybe not right now. And I bring this up because in your assignment you're going to see something about showing whether a matrix is orthogonal. Okay, you have at least one problem where you got to show that a matrix is orthogonal. You got two ways to do that. You can write down the transpose of the matrix, and you can invert the matrix. And it's a simple matrix to invert by any of the methods you have for inverting a matrix. And you probably should do it that way. Now you could get away with doing it this way. Just multiply A by its transpose and see if you get the identity. Better if you actually invert the matrix and look at that product, okay? But it's going to come out pretty much the same either way.